Solutions are made up of two things, a solute and a solvent. Now, in today's lab, we'll be exploring the properties of both using a potato.
And suddenly I'm hungry for French fries.
How can you be thinking about food when we've got so much exciting science to do?
Fine. In this first part of the experiment, we'll be investigating osmosis by placing potato pieces into 3 different solutions. One that is hypotonic in regard to potatoes, a second one that is hypertonic, and a third that is isotonic.
We get to use the potato borer. Now be careful because this bad boy can bore a hole right through your hand. Make sure you hold the potato on the table like this and push the borer in like this.
Now, if the potato piece gets stuck inside the cylinder, just use a glass stirring rod to push it through, like that. Make sure that you label all your weighing belts so that you do not get everything mixed up. And also, when you're recording your masses, make sure you measure up to 3 decimal places.
After you've recorded all these measurements, you'll want to place each of the potatoes into their respective solutions. Now, they'll need to stay in these solutions for 45 minutes. So go ahead and continue on with the rest of your lab while you're waiting for these 45 minutes to be up.
After the 45 minutes has expired, you'll remove the potato pieces and remeasure their textures, lengths, and masses. By comparing the potato pieces before and after the 45 minutes, you can make conclusions about whether the water flowed into or out of the potato pieces.
And remember that water always flows to the higher solute concentration. So the potato that gained the most mass gained the most water. And if your potato lost mass, it lost water.
Once you're done, you can throw away the potato pieces and dispose of the solutions that are in the beaker into the sink.
And today's lab is all about conductivity and bonding. Conductivity is the measurement of a solution's ability to conduct electrical currents.
This experiment will explore the conductivity of both ionic and covalent compounds. You want to make sure that your setup is correct before you start.
In the beginning of this lab, you'll want to prepare aqueous solutions of both sodium chloride and sucrose. And you'll want to obtain 2 grams of your solid on the digital balance like I did earlier.
Make sure you record your mass to up to 3 decimal places. It's okay if you accidentally pour too much sample out, but make sure you never put that sample back into the stock container. Place the excess into the waste container.
Once you add your sodium chloride to the water, you'll want to make sure you stir until the solid completely dissolves into the water.
We first need to test the conductivity probe to make sure that it reads to about 38 microsiemens per centimeter. If it doesn't give this reading, make sure to wash with dishwashing soap and distilled water.
You want to let your conductivity probe set for about 30 seconds before you get your reading so that it can stabilize. And you want to make sure that in between each reading, you wash the probe with distilled water.
When finished with this step, make sure you dispose of the contents in beakers 2 and 3.
In this next part of the lab, we'll see how the solubility of a solution affects its conductivity.
Once you have your samples measured out, make sure you add each of the samples into the proper beaker and stir for 1 minute each.
Sadie, how will I know if my chemicals are dissolving in my water or not?
Well, your chemicals should dissolve or not be able to be seen. Look at mine.
Okay.
So it looks like yours would be insoluble.
Now it's time to measure the conductivity of each of these solutions.
Make sure to wash the conductivity probe between testing for each solution.